Welcome to a demonstration of the Hedvig distributed storage platform. The goal of this demo is to show the power of a single software-defined storage platform that gives IT and DevOps the ability to provision and manage storage from Hedvig's easy-to-use web UI, but also natively within three key infrastructure platforms: VMware, OpenStack, and Docker. It will show the strength of providing block, file, and object storage along with many of our advanced storage features like snapshots and clones from these platforms. Let's start our demo by logging into the Hedvig software. All of the features we'll look at can also be accessed via CLI or a set of RESTful APIs. For demo purposes, we'll use our simple, mobile-friendly web user interface. Here we have a 9-node storage cluster with 123 terabytes of capacity. Each node hosts a metadata process and a data process. Metadata tracks where data is written to the cluster, as well as other key stats of the storage system. And the data process is responsible for storing the data to physical disk. We also have 10 hosts configured with access to the storage system. If we select one of the nodes, we can view its storage pools. Storage pools consist of groups of 3 hard drives or individual solid-state drives. The Hedvig software stores data across these storage pools and across nodes in the cluster to ensure that the system is load balanced and providing optimal availability and performance. In our virtual disk management screen, we see a list of provisioned virtual disks. This view can be customized and filtered to show quick at-a-glance details. To create a new virtual disk, we just select Add Disk. This presents us with all of the available options that can be selected for the best fit with your applications and your data protection requirements. We give the virtual disk a name and choose a size. We can select the disk type. From the UI, this includes block and file. Other available options include deduplication, which performs data reduction for this disk globally against other data stored to the cluster. Choose whether the virtual disk should reside on hard drives or exclusively to flash for performance reasons, what we call pin to flash. Choose block size, and choose replication factor, the number of copies to maintain from 1 copy to 6. Other options are compression and client-side caching. Let's go ahead and choose this option. Client-side caching enables a high-performance boost for reads and eliminates network traffic by maintaining hot data on local SSDs. We also choose our replication policy. Agnostic tells the cluster to replicate data with no specific preference for where copies are placed. Rack-aware distributes data across different racks in the same data center. This offers protection against localized failure. And data center aware replicates to one or more data centers, which can also be a public cloud. Let's choose data center aware and choose our data centers from the drop-down menu. The storage system will now automatically maintain a copy of data in each of these data centers. To complete the process, we select Run, and the disk is created in a matter of seconds. We can click on the virtual disk to see its details. Each of the options we chose during provisioning is reflected here. To make this disk available for use, we add it to one of our hosts. From here, we'll simply follow the standard workflows of connecting and using storage that admins are well used to, and once the disk is in use, we can monitor usage metrics. Just click through and activity on each available disk is shown. You can view statistics on throughput, and you can also change the view so that you can see latency as well as IOPS. Another key aspect of Hedvig is the ability to create point-in-time snapshots of virtual disks. These snapshots enable both the ability to revert to a point in time and to create clones of disks that can be used as well for other purposes like test and dev or backup. To create a snapshot, simply select a virtual disk and choose Snapshots. Click New Snapshot and a space-efficient metadata-based snapshot is created instantly. There's no limit on the number of snaps that can be made. Let's choose one of our snapshots to clone. You can change the properties of a clone disk. This is particularly useful when your clone use case doesn't call for the same class of service or protection. We can, for instance, change to an agnostic replication policy, or change the number of copies. In this case, let's go from 3 copies to 2. Hit Run, and a new virtual disk is created based off of the existing disk and snapshot. Our alerts area gives us visibility into this as well as other recent actions. Here we can click through and see the details of our newly created virtual disk. Now let's look at the Hedvig plugin for VMware vCenter. Once installed in the vSphere web client, you'll notice a new Hedvig option. This enables you to provision and manage Hedvig virtual disks directly from VMware. Just enter the name and login details for one of the server nodes in your storage cluster. Now we can provision storage for VMs with just a few clicks. Let's select Add Hedvig Data Store, and we're presented with a screen that has all of Hedvig's virtual disk options. Next, we choose where to export this NFS virtual disk. And then we choose a host that will use this data store. Let's give the data store a name. Hit Next, where we'll see a summary, and click Finish. Now we create a virtual machine to use the storage. This is all done using standard VMware operations. We give the VM a name, pick our ESX host, and select the NFS disk data store. We choose the guest operating system, and we see a summary and click Finish. In the VM view, we see the VM being created. Now you can simply power on the virtual machine. Once you're up and running with your VMs, you can also create VM-level snapshots and clones directly from the VMware interface. In the menu, you'll see the option to take a Hedvig snapshot. Pick a name and hit OK. All the rights to the virtual machine are quiesced, and the snapshots are taken and tracked by the Hedvig software. If we go back to the menu, we can see the snapshot, and we can now use this snapshot to create a clone. A key benefit here is that Hedvig's zero-copy clones deliver a new VM very quickly and without the need to make a copy of all the data. With Hedvig, the process is fast and space efficient. We now have the VM in our inventory. It's using our NFS disk, and from here, we can simply power it on. Next up is OpenStack with Mirantis. For this demo, we're using Fuel. It's an open source deployment and management tool for OpenStack provided by Mirantis. The opening screen gives us some detail on the makeup of this environment. If we click Plugins, you'll see that we're using Hedvig's Fuel plugin that integrates our Cinder driver. With this integration, you're able to use standard OpenStack operations to create and manage your storage. This makes use and adoption of Hedvig in the OpenStack environment very easy. Let's navigate to OpenStack, where we'll demonstrate how to customize and provision storage from within the OpenStack environment. We'll see that there are already 4 volumes provisioned and in use. Let's go to the admin area and look at how you can create specific volume types, each with unique characteristics that you can select for the best fit with your applications. You can create quality of service or QoS specs that are used to define storage characteristics that are then assigned to a volume type. When using Hedvig, the options for these storage functions correspond to all the available virtual disk features. For instance, here we have a dedupe spec that turns on deduplication with 3-way data center aware replication. We've defined a volume type, Hedvig dedupe, that uses this spec, so when we create volumes, we can assign these characteristics if it suits our workload. Back in our compute management area, let's click Create Volume. Give the volume a name, and under volume type, we select Hedvig dedupe, which uses our dedupe QoS spec. Let's give it a size and click Create Volume. We now have a new volume for our environment. Let's click to see our unique ID, and then let's visit the Hedvig UI to look at this newly created virtual disk. Here it is, and we can quickly see the assigned characteristics. If we open it up and have a look, all the policies assigned have been set, and we see our volume name appended to the description. Through OpenStack, you can also create snapshots. To do so, we select Create Snapshot, give it a name, and click to complete. The new snapshot now appears in our list. We can use this snapshot to create a new volume, what we call a clone. We simply select Create Volume and input a name. You can change the volume type when making a clone if desired. Instead of having the volume deduped and replicated across data centers, you could, for instance, make this a default volume with no dedupe and no replication. To do this, you simply choose a different volume type in the dropdown. Select Create Volume, and the volume is now available. Let's take a look at using object storage with OpenStack and Hedvig. From the Object Store section of OpenStack, we see a list of containers. These 3 containers correspond to 3 virtual disks on the Hedvig platform. Let's create a new container here in the OpenStack interface. We click Create Container and input a name. Let's call it Demo Container 2. Hit Create Container, and we now have a new object container into which we can upload objects like documents, videos, or really any file. Let's go over to Hedvig, where we'll see the new virtual disk created to store the contents of Demo Container 2. Let's open the new one and look at the virtual disk properties. We see an ID and our container name in the name field, and under disk type, we reflect that this is an object store disk. Now let's go take a quick look at how you use these containers. Let's pick a file from our local file system. The file is now listed, and it's stored in our backend Hedvig storage system. And finally, let's look at Hedvig working together with the Cluster HQ Flocker container data management solution to ensure persistent, portable storage for Docker containers. Here we have a containerized app running on a 2-node Linux cluster. Imagine this is a standard web app, perhaps using WordPress or the like, all running in containers. You need this web app to connect to a persistent database. We're using Redis, but this could easily be MySQL or any other database backend. We're using the Hedvig Flocker driver to orchestrate our storage creation from Docker and to enable the storage to follow our container as it moves between hosts. We've defined a single volume here called Hedvig Demo for our container that will be used for the database. We use the Docker Compose Up command to start and run the app. The underlying Hedvig system is a 3-node cluster. And if we look at our virtual disks, we see that we now have one created. When we ran Docker Compose Up, this virtual disk was created automatically via the Hedvig Flocker driver based on our default parameters. Let's go to our web app and create some data. For demo purposes, we'll paste in a few Docker logo images as our persistent data. This will be stored in our backend database. It's the data we want to make sure follows our app wherever it may run. Back on Hedvig, we've achieved a high dedupe rate of 97% since we've pasted that same image many times. And let's take a look at our disk metrics. Our initial write activity is reflected here in our time sequence. Let's stop the container on node 1 and start it on node 2 to simulate an app migration. First, we see that indeed our app is offline and no longer available at the original IP address. If we point our browser, however, to the new node, we see that our application has resumed and we have full access to the stateful data. Flocker has ensured that the Hedvig virtual disk follows the Docker container for seamless access to data no matter where the app may run. Back on the Hedvig storage platform, we can look at our disk read metrics, and we see the read activity now generated by node 2. Thank you for watching. To learn more, visit our website at hedviginc.com.